Good morning, friends. This is the first lecture in mandatory non-credit course module 5. The name of the course is Advanced Electronics Engineering. It is for first year physics cycle. This course is for E&C department, being conducted by myself, Dr. Saurabh Mitra. Today's date is 19/5/2020, and this lecture will be conducted for 1 hour from 12:45 to 1:45 p.m. This chapter is basic introductory chapter for communication system. You have seen in this age of COVID, only one system which is helping everybody for this quarantine period or for this lockdown period are this Jio, Airtel and Vodafone. All these three things are always on. Whenever we are at home, we are enjoying relentless connectivity of communication. So the boredom is little less. We are getting continuous information. We are accessing internet. We are getting to know what is happening throughout the world. So this is the strength of communication system. Even there is very big natural calamity, even if there is pandemic, at any situation, this communication system brings the world together. Through the mobile, it brings the whole world at the palm top. Being E&C engineers, we must know what are the different blocks of a communication system. To start with, here I have shown a very basic block diagram of communication system. Though this is not all, there are going to come many different types of communication systems. There are going to come in different types of communications. The first categorization, whenever we are saying for communication system, is analog communication and digital communication. Analog communication was invented long back. During World War II, it came to its peak. Then analog communication kept on improving, and last 20-30 years we are finding this is totally phased out by digital communication. Yes, digital communications are more complex. Digital communications are using wide bandwidth. Bandwidth we have studied in module number 1. So amount of signal that is being transmitted now is too much compared to whatever was being transmitted 50 or 60 years back. So whenever I am saying bandwidth, that means more amount of information is being transmitted over the same channel or medium. But here we are showing a very basic diagram of analog communication system block. First we are finding there is the information source. Now we have to understand what is meant by information source. Let's take a very simple example. A singer like Lata Mangeshkar is singing. It's in a radio station in Bombay, and the same thing has to be transmitted to Belgavi. So what is the first job? First job is to convert this information for analog communication into a form which can be transmitted. If a person is singing, then basic signal is of, let's say, 3.3 kilohertz, which falls in the audio frequency range. This signal frequency is very less. And first, very important fundamental in communication we should know is, whenever the signal frequency is less, it cannot travel for a longer distance. It cannot penetrate through a very big distance, because for smaller frequencies, the attenuation provided to the signal is becoming too much when it is trying to propagate through the medium. In this case, the medium is air. So if I am trying to transmit 3.3 kilohertz directly from the radio station of Bombay up to Belgavi, not possible, because it will get restricted and it cannot travel maybe even 10 kilometers. So what is the solution? Solution is, we have to first convert the signal into electrical signal. So there will be a microphone kind of a thing. So here, the first stage, information source, the voice signal has to be converted to electrical signal first. There is something called as a transducer. Microphone can be a transducer. It converts the voice signal into electrical signal or electronic signal. Then that electronic signal is given to the transmitter. Electronic signal is having frequency of 3.3 kilohertz. That has to be modulated. Now this is a new word. What is meant by modulation? Modulation is a process, or this is a process found in the transmitter side of communication. Modulator increases the signal frequency. Keeping this thing into mind, that this is a 3.3 kilohertz signal with a certain amplitude. We cannot change the signature of the signal, but what we do is we mix it with a carrier signal. So this basic signal is called as baseband signal or modulating signal. This we want to transmit, but it cannot be transmitted over longer distance. So what we do is we try to mix this baseband signal or modulating signal with a carrier signal of higher frequency. So who modulates whom? This is a very big question. The modulating signal, that is the baseband signal, this thing is modulating the carrier signal. And this whole process happens within that block which is called as transmitter. Now transmitter is not only having this modulator into it, transmitter is having other blocks. So this modulator is there, signal amplifier might be there, mixer, oscillator, all these things together, they are forming the transmitter part. So mainly what transmitter is doing is, transmitter is taking this message signal, then it is modulating the carrier signal. So what we are getting at the output of the transmitter is amplitude enhanced, power enhanced, modulated carrier frequency. So here this transmitted signal is nothing but, this is called as modulated carrier frequency. Now I can say that this frequency is 3.3 kilohertz. Maybe I have used a carrier of 3 megahertz. Just check the difference in the ratio. 3.3 kilohertz is being modulated or is being put into a high frequency signal which is called as carrier signal of 3 megahertz. Now this combined signal is called as modulated signal. This thing is modulating, this thing is changing the property of carrier signal, it is modulated, and that signal is being transmitted. So this is 3 megahertz modulated carrier signal. And remember, this 3.3 kilohertz modulating signal, somebody is singing, all the properties of this 3.3 kilohertz signal is kept intact within this carrier of higher frequency and being transmitted. So this is more or less the transmitter part. There are different types of modulation called as amplitude modulation, frequency modulation, phase modulation, pulse code modulation, other things. So as we go forward in this subject, we will be seeing that. So there are many variations in this transmitter. Okay, so more or less this is the transmitter. We will come to what is meant by channel. Now we are seeing from the beginning that there are mainly two types of communication. One is called as wired communication, another is called as wireless communication. Wired communication came long back, and there the communication was taking place by means of simple communicating wire. Nowadays, this is the age of wireless communication. Here we are using simple air, free air as a communication channel. So the word channel is having significance. So initially this can be wire, it can be optical fiber, it can be free space. So these are the different examples of what is meant by channel. So channel is simply the medium through which the information passes. Okay. So whenever I am using wire, this is called wired communication. Example is telephone, which is nowhere seen now because wireless communication has almost substituted all the wired communication so far. Second is optical fiber. Yes, OFC characteristic is very high bandwidth. So there are, in OFC also there is a physical connectivity between the transmitter and receiver. But in case of free space, or I can say in case of air, you can say mobile communication, there is no direct physical connection. There is nothing but, there is no wire, there is no fiber, there is nothing connected directly but air between the transmitter and receiver. And we are at this age, so we are at the age of wireless communication. So these are the different types of communication. So what is channel? So channel can be air, channel can be OFC, channel can be cable, through which the information passes. And this channel actually connects the transmitter to the receiver side. Now there is a very important factor which is disrupting the communication process, is called as noise. So this is a unwanted signal. This is an unwanted electrical signal which is generally getting added at every stage of the communication, but mainly the noise is getting added through the channels. So whenever this is air is the channel or free space is the channel, amount of noise getting added is too much. So environmental noise getting added in case of free space channel, probability is too high. If it is wired communication, in this case noise is less. In this case noise is very less. In this case noise is very less because the whole signal is enclosed within a optical fiber. But whenever I am talking about free space, in this case amount of noise that is getting added to the channel and disrupting the transmission receiver process is too much. So this is the idea about channel and this is the idea about noise. So whenever this transmitted modulated signal passing through the channel, so channel can be now the distance between Mumbai to Belagavi, as it is said that somebody is singing at Mumbai. First the signal is converted through microphone to electronic signal, then it is modulated, then whichever radio station is there, they are transmitting that high frequency modulated signal to the different destinations where the Mumbai radio should go. Now at Belagavi, if you are tuning a receiver, so whatever radio we are having at our hand, that is nothing but a receiver set. Okay, and that radio is actually extracting the signal, modulated signal from the air. So there is a very important thing which what we have missed. I will just add it now. This is called an antenna. So this is a transmitting antenna and this is a receiving antenna, like this. Okay, so this is a transmitting antenna and this is a receiving antenna. So transmission is given by TX, receiver is given by RX. So transmitting antenna is generally found in the transmitter side. It is actually transmitting very high frequency signals in case of this modulated waveform. And just before the transmitting antenna, there is a